All right, so let's go ahead and get started on 1.8 today. Remember 1.7, 1.8 are both in your Unit 2 test, which will consist of Chapter 2 also, which we'll hit in next week. So let's go ahead and get started into 1.8. All right, so 1.8 is about absolute values, both equations and inequalities. So we're going to go through a few of this. So absolute value was created for the idea of distance. Okay, it is the distance a number is away from 0. Okay, that's our main thing with that. Okay, so if you think about distance, the distance away from 0, okay, if I have this number line, if I say here's 3, well, that's the distance of 3, correct? But if I go to -3, that's still going to be a distance of 3 because distance is always positive. Hence, the absolute value of x is always going to be greater than or equal to 0, meaning x is greater than 0, which would be a positive value, or x is equal to 0, which is just 0. Okay, so they have the absolute value that makes everything positive. So if you take the absolute value of 7, it's still going to be 7. The absolute value of -3 is how far is -3 away from 0 is 3. Now, this is a little different with this negative out front because the absolute value of 7, -7, 7. So this is 7, but then you have the negative out front, which gives you how you can get the absolute value to be negative. Okay, the absolute value itself is positive, and then the negative goes in front of it. Okay, so when we look at it, let's look at a little logic here. If you think about that, okay, 7 gives me 7, -3 gives me 3, so 3 would give me 3, correct? So, okay, so if you think about it here, what could I put in here for x to give me 15? Well, obviously if I put 15 in there, right? Absolute value of 15 is 15. But couldn't I put -15 in there and get 15? Yes. Okay. So using that same idea, 3 times what would give me absolute value would give me 15? Well, 3 times 5 gives me 15. That works. But also a -5 would also work. All right? And even an addition. Well, the obvious one is how can I get 15 in here? Well, 14 plus 1. And then how can I get this to be -15 inside there? Well, -16 plus 1. So -16 and 14. All right? So think about this. How many solutions are we basically looking for? Well, we're usually looking for 2, right? With the exception when the absolute value is equal to 0. Okay, because when it's equal to 0, I want this inside here to be 0. So what makes this 0 in here is a 2. But there is no such thing as a -0, so you're only going to have one answer when it's equal to 0, when the absolute value is equal to 0. Okay, so how do we solve other types of equations? Okay, well, this is a basic, this is a number, here's my x, this is a number, this is a number. We need to first isolate this piece. That piece has to be isolated first before we can do anything. So if we look here, I need to isolate that piece, which means I need to add 8 to both sides. So I'm going to get absolute value of x minus 5 is equal to 12. Okay? Now, because I want 2 answers, or I'm looking for 2 answers, okay, I'm going to separate this. I need to know what x minus 5 is equal to 12, because I want that to be 12, but I also want it to be a -12. So I said x minus 5 is equal to -12. Okay? Now notice there's no more absolute value. When I split this, you drop the absolute values. Now I can solve this. X is 17, and this one, add 5, x is going to be -7. So those are my 2 solutions. Okay? So it's just as simple as that. Isolate and then separate. So step 1, isolate the absolute value. Step 2, separate to 2 equations. Lose the absolute value bars. Okay, so let's follow that. Isolate. So what am I isolating? I'm trying to isolate this. All right, so minus 3. That's going to be 4 times absolute value. X plus 8 is equal to 12. And then I cannot distribute. You do not distribute the 4. You have to divide by 4. Okay, which now gives me x plus 8 is equal to 3. So now I've isolate, now I separate. X plus 8 is equal to 3. X plus 8 is equal to negative 3. Because I want the inside to be negative 3 or 3. So x is going to be subtract 8 and negative 5. X is going to subtract 8 and negative 11. There are my two solutions. Okay. Now, if we look at the next one, I still have to isolate. So this is x minus 5 and absolute values plus 8. So I'm going to subtract 8. So I've got this. I've isolated. Okay, so check number 1 is done. Okay, now, if we think about it, what number can I put inside here? When I take the absolute value, I get a negative 8. Well, if I put a negative 3 there, so if I go negative 3 minus 5, that'd be negative 8, but the absolute value of negative 8 is 8, right? So that doesn't work. Okay, and what happens is there is no number that actually works. Because if I separate and I just solve, that'll be what, negative 3? If I put negative 3 in there, that's what we said, it won't give me the right term, so that doesn't work. So none of this equals, because this is a no solution. Okay, and the rule or the shortcut to this is once you've isolated the absolute value and it's equal to a negative, this always has to be positive. Positive can never equal negative, so you always get that. Okay. All right, so as soon as, even if you have 2/3 x minus 68 over 5 is equal to a negative 1. That is no solution because this is isolated and there's a negative. Okay. Now, how about here? I have a negative out here. Well, this is not isolated, so you cannot choose that answer yet. I've got to still isolate. So this 3 on the bottom, I'm going to go ahead and multiply both sides by 3. Okay, so notice what I have. I got negative 2 times the absolute value all over 3. 3's on the outside is equal to 10. So I'm getting rid of the 3 first, and I get negative 2 times the absolute value of x plus 8 is equal to negative 30. I still have a negative over here. Is it no solution? Not yet. It's not isolated. I've still got to isolate this. Okay, so I got to divide by negative 2. So now I have x plus 8, which is equal to 15. Now it's isolated. Okay, is it positive or negative? Well, it's a positive, so now I separate. X plus 8 is equal to 15. X plus 8 is equal to negative 15. So x is going to equal 7, and x is equal to negative 23. So you cannot assume just because you see the negatives that it's no solution. It must be isolated first. All right, and then the other type of absolute value equations we have to do is when there are two absolute values. Okay, now, in general, you can do this one of two ways, but if you look over here, this side's already isolated, so is this side. So since it's already isolated, I can already separate. And the way we separate is this. 2x is equal to x minus 3, and 2x is equal to x minus 3, but we have to do the opposite of that. So that opposite would actually be negative x plus 3. And now we solve for both. Since I'm already over here, let's go ahead and solve. This will be 3x is equal to 3. Divide by 3. X is 1. Okay. And then over here, separate. X is equal to negative 3. So I get -3 and 1. Okay. So that's equations. So let's go to inequalities. So how do I deal with absolute value inequalities? Well, there's two types. There's ands and there's or problems. Okay? And problems tend to be segments. Or problems tend to be two rays. Okay? And we consider it as the intersection of two. Or is the union. Okay, which means you're putting all the answers together. The intersection, what they have common, the or is just all the answers put in one. Okay, so let's talk about and first. And absolute values, when you have an absolute value that's less than or equal to. Okay, that's going to be an and statement. To show you how that works, if I have the absolute value of less than or equal to 8, it breaks apart to x is less than or equal to 8 and, okay, and x is greater than or equal to -8. Notice this was flipped and this was switched to a negative. All right, now how does this work? Well, if it's an and, you've got, notice what we have. We've got a less than, -8 greater than. But in and, we're talking about intersection, right? It's what they have in common. And then what they have in common is these two. Okay? So essentially, the answer of these is everything between -8 to 8 or -8 to 8, which is the same thing as saying this. Okay. All right. So, which is that compound three-part inequality that we discussed in the last section. Okay. If you remember in the last section, we talked about three-part inequalities. The compound inequalities, this was from the last set of notes. Okay. So, let's try this one. All right. Now, what you must do before you can decide whether it's and or is this has to be isolated. So we still, first step, isolate. So notice this is not isolated yet, so I have to add 6 to both sides. And now I get an isolation of that. All right, so now it's isolated. So now we're going to separate. And the way we separate is the following. X plus 3 is less than 9. And x plus 3, I said 3, 9 there. And we switch it, flip it, and switch it. Okay, and we're going to solve for both. So we're going to subtract 3. So that's going to be x is less than 6 and -3, x is greater than -12. So when I graph that, you're going to have 6 here. You're going to have -12 here. And remember, if it's and, we look for what they have in common. Those two. And remember at the beginning, I said we're almost always going to get a segment. Okay, the segment we're going to get is from -12 to 6. Whoops, it's open, so it's parentheses. So it's from -12 to 6, open. Okay. Now, with and only, and problems only. Okay, just understand that and only, you could have done this. -9 is less than x plus 3, which is less than 9. And it solves the same way. Subtract 3, that's what we did last time. And we get -12 is less than x, which is less than 6, which is that. Okay, but you can only do this kind of step for ands. Okay, ors do not do that. Okay. All right, so let's talk about ors. Ors are our union. Ors are going to be two rays. Ors happen when you isolate, and then you have greater than symbols. Greater than or greater than equal to. Okay, so if we look at the absolute value of greater than 8, that would be the same as saying x is greater than or equal to 8, or x is flip it and switch it, right? Now, when we graph that, that's going to be hard bracket out going bigger, hard bracket going smaller, which is negative infinity to negative 8, union 8 to infinity. Okay? Now, notice two rays, and that's normally what's going to happen. All right, so let's look at this next one. It is isolated, so we're done. I have a greater, so we're going to separate. X plus 8 is greater than 10, or x plus 8, we got to flip it and switch it. Okay, so I'm going to subtract the 8. X is less or greater than 2, or x is less than negative 18. Which, in a union, here's 2, it's going to be an open out that direction, and then negative 18, open this way. And so now I have negative infinity to negative 18, union 2 to infinity. And again, I have the two rays. Okay. All right, so let's look at another one. Here I have a little fraction, but I still need to isolate. So step number 1, subtract 2. And I get 3x minus 6 over 3 is greater or equal to 10. Now it is isolated, so it is an or, because it is isolated. Now, before I separate, I can reduce inside. That's a 1, that's a 1, and that's a 2. So now I'm going to separate. X minus 2 is greater than or equal to 10, or x minus 2, flip it, and switch it. All right, add the 2. X is going to be greater than or equal to 12, or x is going to be less than or equal to negative 8. Draw it out. Here's 12, close bracket to the right. Negative 8, close bracket to the left. Negative infinity to negative 8, closed. 12 to infinity. All right. So if we look at this, notice I have a greater than or equal to and a negative. But is it isolated? I still have to isolate. So what do I have to do? Well, we're going to multiply. Let's go ahead and multiply both sides by negative 2. Now, what have we learned before? Well, this is going to isolate it. But because of multiplying both sides to negative, doesn't that flip our symbol? And I get a positive 16. Which, now that it's isolated, this now becomes an and statement. So it's going to be a segment. So now I got to separate. 3x plus 7 is less than or equal to 16, and 3x plus 7 is greater than or equal to negative 16. Flip it and switch it. All right, so I'm going to subtract the 7, which would be, what, 9. X is going to be less than or equal to 3, and 3x will be greater than or equal to negative 23. X is going to be greater than or equal to negative 23 over 3. All right, so this should be a segment. Greater than the negative, less than the positive. It does flip. Okay, it does go this way and this way, right? So what we're going to actually have, if you would look at this, is here's my 3. It's going to be closed. Here's my negative 23 over 3. It's closed, and it's in between those two. Or it's negative 23 over 3, comma 3, and they're both closed. As long as you know it's an and, it's going to be an absolute value and it's going to be closed, or it's going to be a segment. All right, last two things. One, logic. Let's look at this for a second. If I isolate it, okay, so these are isolated. I have an absolute value is less than a negative. Now we did the equal to, remember? Remember we talked about x, absolute value cannot equal 0, or cannot equal negative, excuse me. Okay, that was no solution because this is always positive. So think about the same thing, it's always positive. Can a positive ever be less than a negative? No, this is no solution. How about an absolute value being greater than a negative? Well, this is positive. Is a positive ever greater than a negative? Yeah, always. Always. So this would be all real numbers, or interval notation wise, negative infinity to infinity. How about a positive? That's what this is, right? Greater than or equal to 0. Is a positive always bigger than 0? Yeah. Can it ever equal 0? Yeah. Positive 0 is 0. So this one's all real numbers. All right, and then the last one I have here is absolute value less than or equal to 0. So it's positive, right? Can a positive ever be less than 0? No. But can it be equal to? This little piece right here is important. So the only thing here is x can equal 0. Okay? So whatever x is can equal 0, you're going to get one solution. Whatever this is equal to 0. So if you had something like this, x plus 3 is less than or equal to 0, the less than part doesn't matter. You can just automatically do x plus 3 is equal to 0, and x has to be negative 3. One solution. All right, so last one. Just one more problem, okay? So I have all this. I've got to isolate first, right? So we're going to add the 8. So far, so good. Greater than or equal to, what's that, 42? All right, so let's divide by negative 3. I get 2x minus 15. We got to switch it, correct? And that's going to be, what, a negative 14. So now I have isolated, check, less than or equal to, which would be an and, a negative. Well, wait a minute. So if I have this negative, let's look. What did we say? Absolute value less than or equal to a negative. Let's go back up here. Less than a negative. Okay. Well, can it equal negative? Can it be less than a negative? No. So because of this, and it's isolated, the answer is no solution. Okay. All right. So I hope this helps. Okay. This ends chapter 1 for us, and we'll get into chapter 2 next week. Good luck.